Welcome back, Algebra 2 students. We are in lesson 52, and we're going to talk about chemical mixture problems, specifically type A. Type A chemical mixture problems is very similar to what we used to do with our number of nickels and number of dimes problems. We would create two equations. One of them we would turn into a substitution, and then we would solve for the other with the substitution. So let's go through that. We're going to apply that to this problem here. A druggist has one solution that is 10% iodine and another solution that is 50% iodine. How much of each solution should the druggist use to get 100 milliliters of a mixture that is 20%? All right, so one of the things that we need to do is differentiate between 10% iodine and 50% iodine. When we had the number of nickels and the number of dimes, it was easy. It was easy because they were different letters. What we need to do now is figure out a way to differentiate that. So what we're going to do is we're going to say that the iodine, the 10% iodine, is going to be poured. And the 50% iodine is going to be dumped, right? So that gives us a little bit easier way to keep track of it. So we're going to say the iodine that was poured in plus the iodine that was dumped in gave us 100 milliliters of the mixture, right? So now we're going to do the value of those. So the value of the poured in iodine is 0.1 times the quantity. And we need to have something here. 50% would be 0.5 times the amount that was dumped in. And that gave us a 20% solution, which is 0.2 of the 100 milliliters, right? Okay, now we need to find something that we can sub in. And we are going to sub in for the poured in amount. So let's say the iodine that was dumped in is equal to 100 minus the iodine that was poured in. Okay? So now we have something we can sub. So 0.1 of the iodine poured plus 0.5 times 100 minus the iodine that was poured equals 0.2 times 100 milliliters. Now we can do some math. 0.1 plus, this is going to be 50, because half of that is 50, minus 0.5 iodine poured equals 20, because 0.2 times 100 is 20. All right, so now we can subtract 50 from both sides. That's going to leave 30. That's negative 30, right? And that cancels. And 0.1 minus 0.5 is going to be a negative 0.4 IP poured in. So when we divide 30 by negative 0.4, we get that the amount of iodine that was poured in was 75. That was poured. And if we remember, the iodine that was poured in was the 10% solution. So we're going to sub in 75 plus the iodine that was dumped equals 100. We subtract 75 from both sides. We find that the iodine that was dumped in is 25. Okay? And so we can add that to our solution here. The iodine dumped was 25. So the iodine poured was the 10% solution, and the iodine that was dumped was the 50% solution. So we work these problems the exact same way that we did for the number of nickels and number of dimes. It's just that we're using decimals, and that's really the biggest difference. It makes it a little bit harder, but we're just going to use the decimals, and it'll be fine. All right, so let's look at another one. 52.2. Let me clear this. And I'm going to type this for you because you'll be able to read it. All right, so this one is 52.2. A chemist has one solution that is 10% salt and 90% water, and another solution that is only 2% salt. How many milliliters of each should the chemist use to make a 1400 milliliter of a solution, or to make 1400 milliliters of a solution that is 6% salt? So we're going to do the same thing we did before. We're going to make us some buckets, and we're going to figure a way to tell the difference. So we have the salt, 10% salt. Why don't we call that S1 10? Let's call that S10. And let's call the salt that's 2%, let's call that S2. I think that'll help us tell the difference, don't you? So we know that some quantity of S10 plus some quantity of S2 is going to equal 1400. All right. So now we are going to make our valuation statement, and we're going to say that 0.1 of the S10 plus, and this is 2%, so that's 0.02 of the S2 equals, we need 6%, so that's 0.06 of 1400. All right, man, that's a lot of decimals. So now we need to come up with a substitution value. Why don't we substitute in for, let's look at S2. So I'm going to say S2 equals 1400 minus however much is S10. So now we can sub in for S2. So 0.1 times however much is in S10 plus 0.02, and then S2 equals 1400 minus S10 equals 0.06. I should have left that 0 out. It's fine. Times 1400. All right. We're about to the point where I need a calculator. So I'm going to pull one up. I don't know why I closed it. All right, here we go. So I know what this is. This one's easy. 0.1 to the 10% solution. And then we have, let's do 0.2. So 1400 times 0.02 equals 28. All right, so 28 minus 0.02 S10, right? Equals, and let's do again, 0.06 times 1400 equals 84. All right. Now I can subtract 28 from both sides, and I'm going to use my calculator because my brain hurts. Minus 28 equals 56. That's 56 here. And we are going to add these together, or actually we're going to subtract these from one another. That's the minus sign right there because it's canceled. 0.1 minus 0.025 is 0.0. Oh, I'm sorry. I read that as a 5. It's not a 5, so it'd be 0.8, and it's S10. That just says I need to have better handwriting. It's an S, Tracy. All right, so 0.02. 1 minus 0.02 leaves 0.08. And that's S10. Right? All right, so we're going to divide 56 by 0.08, and that equals 700. So the solution, that is 10%, we need 700 milliliters of that. And 1400 minus 700 means we need 700 milliliters of the solution that is 2%. And that is the answer. So there we go. So you can see these are the same types of problems. They're just a little bit harder because we're using the same thing. So we have to figure out a creative way to use our subscripted variable and label it. And we're also using decimals now because we're doing percentages. So that adds a level of complexity as well. All right, and that is all we have for lesson 52. So I will see you guys in lesson 53.